Okay, so here is the D-5 video. So I'm going to do 2 examples, and then for the practice, you're going to do 6 examples that are very similar. So example 1, for the function below, A, find the slope of the tangent line at 1, -9, and then B, find the point at which the instantaneous rate of change of the function is 13. Okay, so this first one, I guess when you're, okay, well, first of all, let me write up here. Okay, slope of tangent line equals the instantaneous rate of change equals the derivative. So if they're asking you for the slope of the tangent line or the instantaneous rate of change, you know you need to take the derivative. So, so for A, find the slope of the tangent line at 1, -9. So we need to take the derivative. So they want the derivative at 1, -9. So they want the derivative at 1, -9. All right, that's what they want there. They want the derivative at that point. So you've got to take the derivative. So this is going to be y prime equals 10x minus 7. Okay. Yeah, so they want the derivative. So I'll be like y prime. You know what I can do? Okay, so basically I need to plug in for this. So y prime at 1, -9 equals, okay, so here's 1, -9. This is the x, this is the y. So really I don't even need the y in order to know the slope because this slope only depends on x. So 10 times 1 minus 7. 10 minus 7 is 3. Okay, so that is the answer to A. So the slope of the tangent line at 1, -9 is 3. Okay, so now this time for B, they want us to find the point at which the instantaneous rate of change of the function is 13. Okay, well, what is the instantaneous rate of change? That's the derivative. So they want to find the point at which the derivative is 13. The point at which the derivative is 13. So, so they want the point when the derivative is 13. So again, we're going to use the derivative. All right, we already know y prime equals 10x minus 7. But how are we going to find the point when the derivative is 13? Well, it's the derivative that they want to be 13. So 13 is going to go in for y prime because that's the derivative. So 13 goes in for y prime. All right, so this is 10x equals 20. And then this is x equals 2. So we know that when y prime is for y prime to be 13, we need x to be 2. All right, but we need a point. So 2 is going to be the x coordinate. Now, how do you find the y coordinate? And this is something that students, AP Calc students, struggle with a lot. Are you going to plug this number into the derivative or into the original? Well, guys, this point that we're looking for, where is this point? This point is on the original. So it's the point on the original function at which the instantaneous rate of change is 13. So I need to plug this x back into the original. So y equals 5 times 2 squared minus 7 times 2. And then whatever this is. This is, wait, what is that? That's 20, right? 20 minus 14 minus 7, -1. Okay, So at this point, 2, -1 on the original graph, the derivative is 13. So the slope of the tangent line is 13 there. Okay, so sometimes you're finding the derivative, and then other times you're being given the derivative. All right, if you're finding the derivative, you plug the x in to the derivative function. But if you are given the derivative, you take the derivative function and you put the derivative in for y prime, and then you solve from there. Okay, anyway, I'm probably talking too much. So this one, we're going to find the instantaneous rate of change at 6, -6. So instantaneous rate of change, that's derivative. So they want the derivative at 6, -6. So I'm going to do y prime equals, all right, so the 3 comes down. So this ends up just being x squared. Or actually, you know what? Let me translate this. So this is not y prime, this is just y. So y is 1/3 x to the 3rd minus 3/2 x squared minus 4x. I just want everything to look like ax to the n. All right, so 1/3 times 3 is 1. All right, yeah. Minus 3x minus 4. Okay. And I'm going to plug, so I want y prime at 6, -6. So that's the x, that's the y. I've only got x's. So it's going to be 6 squared minus 3 times 6 minus 4. 14. Okay, so the derivative is 14 at that point. All right, now the next one, we want to find the point or points at which the tangent line to the graph is horizontal. Guys, you need to know that a horizontal line has a slope of 0. I remember m was used for slope, like mx plus b in a line. But the slope is y prime. All right. Oh yeah, and even up here, guys, when you could put y prime in for the derivative. So we want the point when the derivative is 13. And what is the derivative? The derivative is y prime. So up there. Yeah, so for a horizontal line, if the tangent line is horizontal, then its slope is 0. So that means that y prime is 0. Because that's the slope of the tangent line. Okay, so I know that x squared minus 3x minus 4, I know that's y prime, first of all. And I want to find the point where y prime is 0. So x squared minus 3x minus 4 equals 0. And then you got a factor. So this is x squared multiply to make -4 and add to make -3. So minus 4x plus 1x minus 4 equals 0. X minus 4 plus 1, x minus 4. Okay, so we've got an x coordinate of -1 and an x coordinate of 4. So we're going to have two points in our answer. All right, so if this x coordinate will have -1, this one will have 4. Now remember, these points that we're looking for are on the original graph. So these x's go back into the original. So this one right here. So just in my calculator, I'm doing -1 cubed divided by 3 minus 3/2 -1 squared minus 4 times -1. I hope I'm right. Okay, and I got 13/6. Okay, I got a decimal and then I made it a fraction by doing, what is it? Math, enter, I think. Okay, and now I'm going to plug 4 in there. Oh, you know what? And I mean, you could do this differently than me. If I go second enter, this will come up. that I plugged the -1 into, and I'm going to go back. I'm going to delete the minus sign, the negative sign, and I'm going to type a 4 on top of the 1. So I delete the minus sign, and I just type a 4 on top of the 1. Delete 4. Math, enter, enter. Negative 56/3. Alrighty, guys. So there's that. I hope that was clear, and I will talk to you soon.